Okay, we've literally all been there, right? Staring at this tangled web of legacy code, absolutely terrified to touch anything because you know fixing one little bug is going to inevitably spawn three more. It's a universal headache. So in this explainer, we're going to cure that pain. We're going to look at moving away from the standard layered approach and shifting toward a clean or hexagonal architecture. It's a real game changer.
Here is our roadmap for today's explainer. 1. The problem with layers. 2. The dependency inversion principle. 3. Enter hexagonal architecture. 4. Architecturally expressive code. And 5. Implementing a use case.
So let's dive right into section 1, the problem with layers.
Now, we've all been taught the conventional three-layer architecture. You've got web at the top, domain in the middle, and persistence at the bottom. But here's the catch. Everything flows downward to the database. This baseline setup fundamentally promotes database-driven design, making the database, not your business behavior, the actual foundation of absolutely everything you build. And honestly, from a business perspective, that makes zero sense. We should really be modeling behavior first, not the state of a database.
And when we use database entities directly inside the domain layer, it creates a massive issue with strong coupling. Suddenly, your core business rules have to care about the quirky mechanics of eager versus lazy loading or managing database transactions. Your pure, beautiful logic gets entirely bogged down in persistence mechanics. It just makes the whole system rigid, brittle, and incredibly frustrating to adapt over time.
But, it gets worse when the pressure is on. When deadlines loom, we take shortcuts. Need a utility class to be accessible everywhere? Well, just drop it into the bottommost layer. So the persistence layer slowly swells up and grows fat. It basically creates a codebase of broken windows, where one sloppy shortcut lowers the psychological barrier, basically inviting the next developer to do exactly the same thing.
Eventually, entire layers just get skipped. The web layer starts talking straight to persistence, just to update a single field. And this scatters your crucial domain logic all over the place. The result? Testing becomes an absolute nightmare. And parallel work? Yeah, nearly impossible, because everyone is stepping on each other's toes trying to modify the exact same files.
Moving on to section 2, the dependency inversion principle.
To actually understand the fix here, we first have to clarify the single responsibility principle. There's this huge myth out there that it simply means a component should do only one thing. Actually, scratch that. The reality is it means a component should have only one reason to change. Think about it. If your component depends on 5 other components, it literally has 5 entirely different reasons it might break.
Which brings us to the ultimate power move, the dependency inversion principle. Listen to this quote for a second. We can turn around the direction of any dependency within our codebase. I mean, that is incredibly empowering. We don't have to be victims to the downward flow of standard layers. We can take control.
So what does this actually look like in practice? Well, by introducing a really simple interface, like a repository interface, right inside the domain layer, we physically flip the dependency arrow. Now the persistence layer depends on the domain, implementing that interface. Just like that, we have successfully liberated our core business logic from the database.
That brings us to section 3, enter hexagonal architecture. Whether it's represented as the concentric circles of clean architecture or the hexagonal ports and adapters architecture, both of these models enforce one absolute golden rule. All dependencies must point inward. In this setup, the domain is king. It has no outward-facing dependencies to the web or the database whatsoever. It simply provides ports for those outside adapters to seamlessly plug into.
Let's move to section 4, architecturally expressive code.
When we organize our files, we usually group them by layer or by feature. But honestly, both of those approaches just bury the underlying architecture. You can't easily spot your incoming and outgoing ports. It ends up turning your daily workflow into a frustrating game of hide and seek, just trying to understand the flow of data. Instead, we want what is beautifully termed a screaming architecture. This is a package structure that literally screams its intention and design right at you. You can instantly locate your adapters, your use cases, and your entities just by reading the folder names. If you need the web adapter, you go straight to the adapter/web package. No more guesswork for sure.
Now, to connect these isolated components without manually instantiating classes everywhere, we use dependency injection. A totally neutral component sits completely outside and seamlessly provides your application with the actual objects that implement our port interfaces. The application layer literally never knows what database you're using. It just gets an object that gets the job done.
Finally, Section 5, implementing a use case.
Every specialized, narrow use case you write should meticulously follow 4 specific phases. First, you take the input from the adapter. Second, you validate the business rules, and notice this isn't basic input validation, this is your core business logic. Third, you manipulate the model state. And fourth, return the output. Following these exact steps keeps our business rules perfectly and strictly isolated. And by creating a separate service class for every single use case, we totally dodge those massive, unmaintainable God files that plague layered architectures. Need to edit the send money logic? You just open the send money service. It means smaller classes, highly testable code, and best of all, it completely eliminates those dreaded merge conflicts.
Which brings us to the end of today's explainer. I want to leave you with a final provocative thought. Does your package structure scream its architecture, or is it just hiding broken windows? Think about the code you're going to write tomorrow. Are you building a flexible, scalable system where the domain is truly king, or are you just sweeping the mess under another layer? The choice is entirely yours. Keep structuring, and I'll catch you in the next explainer.